which means he gets to talk and no one interrupts her, not even me.
Alright, so we already started yesterday with place values. So we're going to start by doing the solve and share, which it says place value blocks are shown for 1, 10, and 100. What patterns in the shapes and sizes of the blocks do you see? So looking at this picture, what patterns do you see here? So I'll wait till I see a little bit more hands.
Are you supposed to write it down?
Yeah. So I'll also write it out and then I'll call on someone. So go ahead and work on it.
You write it down. You should be writing this down. Okay, sir, I need to write it down. You need to write it down. I need to write it down. I need to write the answer down. Right? Where's that?
So what patterns do you see
It says,
here?
what pattern do you see? Now what is the value? What pattern do you see? Not what value, what pattern. What patterns do you see?
About 30 more seconds.
See pattern? What's the pattern?
Alright. Malik.
The pattern I see is that each block gets bigger and bigger.
Each block gets bigger and bigger. Okay, that's something. Preston.
So like the pattern I think is like each is like ones like 100s or like 110 or like 1 1s.
One. Okay, so that makes me think of the place value chart. We'll go into that in a second. Melody.
There's a small block, there's a tall block, and there's a big block.
Okay, so it kind of goes along with what Malik said. And then Evie and then Leah.
They're all combinations of one block.
You said combinations of one block? What do you mean by that?
All of them. There's one of these is on each one.
So, okay, so how many ones do you think fit in this then? 10? Then what about here? I think that is a perfect transition to what we were about to say. Did I say Malia? Did you have anything you wanted to add before we continue?
Yes. The pattern that I see is they all had the digit 1.
1. Okay. Yeah, so what we're going to do is we're going to run with that. And you all were on the right track and it was all right. One thing I do want to take off is about what Evie said about it being 1 and then this fits here. Over here, have you ever seen these before? Or worked with them in old math classes? Alright. This little cube right here, what does this mean? This is a 1. So if I have 10 of these, do you think that makes up this?
Yes.
So what is this called? Tens. What do you think the next step might be?
15.
15?
No.
So if this went from 1 to 10,
100.
100. That's 100. That's 100.
100? So how many of these do you think might be in this?
10.
Okay. What do you think comes after this?
1,000.
100 million.
100,000.
What is you? So look at this board. This is the same size as this, and this is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these, right? And you would stack it. So if we had 2 of these, how many would that be? 20 of these? 21. Technically it would be the same, but you would always go to the tens place. So how many of these did you say would make up this right here? 10. Perfect. So let's run with that, see what we had next. So the pattern is what? We were talking about place values before? Okay. So when we use our place value chart, we can remember these. these models, you can see that the overall trend, I think someone mentioned this when we're talking about patterns, is it goes by 10. So it starts from 1 to 10, it's by 10, and then it's multiplied again by another 10, because there's 10 of these you said. You just went over that. You said 10 of these 10s. These right here. You said 10 of these make the hundreds. You add 10 of these, you times it by 10, which means you have 10 hundreds. If you were to stack 10 of these side by side, and you kept going, 10 of these, which means multiplied, would make 1,000. So, if you want to think of a way to remember that, you could just add a 0. Whenever you times anything by 10, you add a 0, right? So if we had the 1, we wanted to make it 10, what would we do? Add a 0. If we wanted to make it 100, what would you do?
Add a 0.
If you wanted to make it 1,000, what would you do?
Add a 0.
And then you would know because there would be a comma here. How many spots is there until you have another comma? It goes by
3.
3. So if this is 1,000, we add a comma, another few zeros. This is 1,000, but what would this be?
Million.
And then it would go by billion and so on, right? Perfect.
There's actually a video.
And there is a video to go with that, so let's watch that real fast. Let's see what they have to say.
We're going to answer the question, what is science?
Hello and thank you for watching. Today's video is going to be over the times 10 rule of place value. Before we get into the rule, we do need to talk about multiplying by 10 and 100. Here are some examples here. Now, in these examples you see 10 times 2, and I know that that equals 20. Now 10 ends in a 0. So that means my answer when I multiply by 10 will end in a 0. 10 times 4 is 40. 10 ends in a 0, my answer ends in a 0. 10 times 6 is 60, and the same rule applies. Let's look at some other examples. You have 3 times 4, 3 times 40, and 3 times 400. Well, the basic fact here is 3 times 4, and I know that that's 12. 3 times 40 is going to be 120. Now, one of my factors ends in a 0, so my answer will end in a 0. And 3 times 400 is 1,200. I see that 400 ends in 2 zeros, and so my answer will end in 2 zeros. Let's look at one more example. Now this one, 5 times 8, the answer to that actually is 40, and 40 ends in a 0, but it's not because one of my factors ended in a 0. That's just the answer to that multiplication fact. 5 times 80 is 400, and that 0 is at the end of your answer. And 5 times 800 is 4,000. So these are some examples of multiplying by 10 and 100 and some of the patterns you'll see when multiplying times numbers that end in a 0 and 100 ending in 2 zeros. So let's get into this times 10 rule of place value. So you have to pay attention to two things whenever you're looking at numbers to see if they follow the times 10 rule. You have to have two digits that are the same, and those two digits have to be next to each other. Let me give you an example of what I mean. Let's take the number 522. I have two digits that are the same, 2 and 2, and those two digits are next to each other. So this number would follow the times 10 rule of place value. Now, let's look at this rule a little more. The 2 in the ones place is worth 2, the tens place is worth 20, and the hundreds place is worth 500. So here's where the rule comes into play. When I'm moving in this direction, I am multiplying the ones place by 10. So 2 times 10 gives me 20. And I would read this description like this. The 2 in the tens place is 10 times greater than the 2 in the ones place. And that is the times 10 rule of place value. Let's look at another example. Here I have 4,431. And as you can see, I have my two digits, they are the same, and they are next to each other, so the times 10 rule applies to this number. Now, the ones place is worth 1, tens place is worth 30, hundreds place is worth 400, and the thousands place is worth 4,000. Here's where the times 10 rule plays in. If I move in this direction, I take the 4 in the hundreds place, 400, and I multiply it by 10, and that gives me 4,000. So when I'm talking about this relationship, I can say that the 4 in the thousands place is 10 times greater than the 4 in the hundreds place. And that is the times 10 rule of place value. Now, if we go in this direction to get 10 times greater, then if I moved in the opposite direction, I would be finding numbers that are 10 times less. And let's talk about that because you're going to see numbers like that as well. Now, moving in this direction, I would take my 20, I would divide it by 10, and I would get 2. So I would say that the 2 in the ones place is 10 times less than the 2 in the tens place. And I could also say that the 2 in the ones place is 1/10 the value of the 2 in the tens place. Let's look at it with our 4,431 number. Again, moving in this direction, I can say that 4,000, if I divide it by 10, I would get 400. And so I would say that the 4 in the hundreds place is 10 times less than the 4 in the thousands place. I can also say that the 4 in the hundreds place is 1/10 the value of the 4 in the thousands place. And that is the times 10 rule of place value. So here you really see the rule of place value play out. Here's how you read this number, 444,444. And all the digits are the same, and all of the digits are next to each other. So the times 10 rule really plays out on this number. So if I'm going in this direction, the 4 in the ones place, and I go here times 10, I get 40. And then 40 times 10 gives me 400. 400 times 10 gives me 4,000. And I could keep going in this direction, multiplying each digit by 10 to get the next greatest number, going to the left. Now, the place value rule also applies if I'm going towards the right. 400,000 divided by 10 gives me 40,000. 40,000 divided by 10 gives me 4,000. And I could keep going in this direction in the same way, and my number would get smaller, the value would get smaller. So let's answer a question using the times 10 rule. Here you have the question in the number 2,577,398, the 7 in...
Alright, so in this number, the 7 is what? Right here in the 10,000. So this is what? What place value is this? Malik Jones? So this is in 1,000, so what does this represent?
1,000.
Well, it's 7,000. So then it says the 7 in the 10,000s place, so would that be this one, right?
Yeah.
Okay, so what does this represent?
70,000.
70,000. So if we were to fill in the blank, 70,000. So times blank, then the 7 and 1,000. So if this is 7,000 and this is 70,000, or this is 7, this is 70,000. How many times more is this number than this number? Malia. 10. And how do you know that?
Because it's the same number and also 7 times 10 equals 70.
Yeah, so you moved one place value over, so you add the 0, right? So because there's 1 0, that means 10. So let's continue.
In the 10,000s place is blank times blank, then the 7 in the thousands place. Well, here's the 7 in the 10,000s place. Here's the 7 in the thousands place. And the 7 in the 10,000s place is 10 times greater than the 7 in the thousands place. Because if I go in this direction and I multiply times 10, I get a number that's 10 times greater. So I would write in the 7 in the 10 thousands place is 10 times greater than the 7 in the thousands place. Let's answer one more question over the times 10 rule of place value. Which number below has a digit in the thousands place that is 10 times greater than the digit in the hundreds place? So you need to look at your answer choices and look.
Okay. Take a second. It says, which number below has a digit in the thousands place that is 10 times greater than a digit in the hundreds place? Think about that for a second. Raise your hand if you think it's A. Raise your hand if you think it's B. Raise your hand if you think it's C. And then raise your hand if you think it's D. Okay.
Look at the thousands place and the hundreds place. I see in A that the thousands place is a 7 and the hundreds place is a 7. So the times 10 rule does apply to that number because I have two digits that are the same and they're next to each other in the places that they're asking me about. In this case, here's the thousands place. I have a 7 and a 0 in the hundreds place. This one will not work because it's not the same digit. C, I have a 7 in the thousands place, but I have a 6 in the hundreds place. That one will not work either. And D, I have a 7 in the thousands place, but I have a 1 in the hundreds place. So I do not have two digits that are the same and next to each other. So is it true that the 7 in the thousands place is 10 times greater than the 7 in the hundreds place? Yes, this is true of A, 5,457,798. I hope this video helped you understand the times 10 rule of place value a little better. If you'd like to see more helpful math videos in the future, please like and subscribe to my channel at 10, and that gives.
Okay. Any questions on that? Okay. So then let's do the convincing.
Actually, let's just go through that. We're all videoed out. Okay, so just make that one bigger. Actually, click on the diamond.
So what?
Right in the middle. Did we do the convince me yet? Let's just go to the other one.
All right. Do you have any questions on what we just talked about?
We're doing groups.
So go ahead. Do you remember your math groups that we got you into yesterday?
Yes.
Perfect. So you're going to get into that, and then with them, you're going to independently work on questions 3 through 5. Got it?
12 minutes for now, okay? 12 minutes.
All right. Go ahead and get in your groups.